created the test. I am in the process of working on the answer key. Well, I'm making sure that it doesn't, there's no mistakes on there. Because I tend to make mistakes. So that is tomorrow morning. For those of you that were unaware, it's been there for a while. Hopefully you were aware. Hopefully it's not a big surprise to anyone. There's the outline that I posted. When did I do that? Who was it that was asking me?
Can you make a cheat sheet today?
You can make a cheat sheet today? I posted it yesterday at 3 o'clock. No, Sunday at 3 o'clock. Okay, so I will expect you to know that, you don't even have to write this down because it's there, right? You can go look at it anytime you want. Know the types of graphs, linear, quadratic, inverse. I'll tell you right now, it's just multiple choice. Which one is this? Because it's easy to mark and all that stuff. You should know the 3 conventions for showing vector direction, and I had a couple people asking about that. So what I'm talking about there is things like 30 degrees south of east, or east 30 south, or that would be a bearing of 120. All of those 3 are equivalent to each other, so you should be familiar with them. And I think what I did was I just made multiple choice questions, drew a vector and said, which one of these is that? So again, easy to mark, but also checks to see if you understand the vector direction conventions. Be able to use a graph. There will be a question where you have to come up with something off the graph. You should know the terms model, laws, and theories and be able to explain them with examples. Do you want me to refresh your memory about those?
Yeah.
So a scientific model is something that helps us to explain, right? It's usually a physical representation of something that we can't see. Good examples would be like the globe, the atomic model, the solar system model, the that whole plate tectonic thing about the Earth's crust. You know how that works? Big giant plates, the Earth made up like jigsaw puzzles. That would be another example. A law. If you say to me that a law is something that has been proven, I will shake my finger at you and I will write on your test what word. Remember the British guy that looked like Iron Man? Video? It's rubbish, right? A law, the difference between a law and a theory. First of all, let's talk about a theory. A theory is not something that hasn't been proven, right? There are 2 types of theories. And did I even include that? Did I even include that in my outline? I don't know if I did. I did not, but so let's add that in here. Right here. So you should know the difference between a robust theory and a speculative theory. Does anyone remember what the difference is? It's kind of like a spectrum, kind of like a scale. Sorry, which one is which? Robust is which one, sorry? That a lot of people do believe? Yes, robust means that there's a lot of evidence, generally widely accepted. Basically, it's accepted as the correct explanation. It's fact. Okay. The other one is speculative.
Hey, Mr. Bennett, for that east of 20 south.
Oh, did it disappear? You want me to write it down there again?
Yeah. Speculative would be not very many people.
That's right. I'll talk about speculative right away. So east 30 south, or 30 degrees south of east, or bearing 120. Speculative means that it's still in the beginning stages. Not as many people believe it. Not widely accepted. Still in the initial sort of discovery phase kind of thing. Okay? So a theory is simply, it can be, basically it's I wanted to say a statement, but that's not true. It's a collection of explanations that try to explain why something occurs. It's the explanation for why. Okay? And a very good example of a robust theory would be theory of evolution. Right? It's taught in schools, generally widely accepted. There are still some pockets of disbelief. But for the most part, people agree that it includes the correct answer. kind of thing. It's factual, right? There might be some small tweaks to it, but generally, structurally, it's widely accepted. Okay, that's a theory. Will we ever prove it, Lane? Will we ever prove evolution? No, all we'll ever do is just keep adding to the piles of evidence that are already there. Okay? It will never become a law, because what is a law? No, do not use the word truly. A law is something that always happens. It is a regularity or pattern in nature. An observed regularity. Something that always happens. 30 degrees south of east. South of east. Example, what goes up must come down. Every time you throw something up, it comes down. That's a law. Right? That's the easiest one there is. Newton's law. The force is proportional to the acceleration. It's the law. It always happens. We observe it to always happen. It has not been proven. It's just something that we always see or observe. When I smack Cole in the face, he gets angry. That's a law. Although I've never tried it. I've never observed it. Should we give it a whirl?
Yeah.
How about if I just steal his car? No? You'll be the volunteer, okay. Okay, so you should know the difference between a model, law, and a theory, and be able to explain them with examples. And I've given you some just now. Be able to create a graph both on paper and on Excel. If you were one of those people that let someone else do it on Excel, the tissue box is over here. You need to be able to create a graph on Excel. If you don't know how to do that, you have today's period to figure out how to do that. On the computer. Part of the test. You have to be able to explain the law of parsimony. Remember the horse that could do math?
Yeah.
What's the law of parsimony say? Anybody remember? The simplest explanation is quite likely the most correct. Hey, Jay. Yeah, go ahead. The simplest explanation is the most likely, right? The one with the least number of assumptions, the one that's the simplest. That's the law of parsimony. You should know the difference between a vector and a scalar. You need to be able to draw a scale drawing of a vector. That brings me to a good point. For tomorrow, you will need a ruler and a protractor. You get half of that. You get, okay. Yeah, you will need a calculator. That's true. Yes. Yeah.
What are some examples of models?
Models were things like the globe, solar system model, the atomic model, the plate tectonic model of the Earth, model of the universe, I guess. I don't know. Scientific model. I'm not looking for things like, like fashion magazine model. Sports Illustrated models. Not looking for that. You need to be able to add vectors by Pythagoras and scale drawing. How do you know the difference? If it's got a 90-degree angle, it's going to be? If it's got a, yeah, okay, yeah, you're scaring me. Yeah. And you need to be able to subtract vectors by Pythagoras and scale drawing. And how do you know when to subtract? There's two ways. One is the easiest. Yeah, when it says minus in the question. You subtract. And the other one is if you're solving for like the plane speed or the wind speed or the boat speed or the current speed, right? Not the result. Then you do subtract. That's it. Yeah. I don't know why not. You should. I've taught you all of this. I know you can all do all this. There might be a few little pockets of not understanding, but today's the day to solve those. Make your cheat sheet, take a piece of paper, fold it in half, put anything you want on there. Guaranteed 100%, right? I don't see why not. What kind of silly mistakes do people make? Yeah, they use Pythagoras when it's not a right triangle. That's a good one, Lane. That's the one that makes my hair fall out. You can tell it's been pretty common. Forget to put arrowheads. They get east and west mixed up. I don't know why. Never north and south. Always east and west. Oddly enough. I don't know. They forget to go on scale drawings, they forget to go 1 centimeter equals, and it's like kilometers per hour. Yes, that's possible. 1 centimeter represents so many kilometers per hour. That's possible. Okay? That's mostly it. Cole was asking about your vector golf. And I do have those marked. I just have to find them. They're right here. I was very pleased. I was kind of disappointed because when I came in, I was like, no one handed these in? And then they were in a folder like over here. So I have them. But, having said that, I don't have everyone. Don't record what? Okay, well, I'll stop recording. I'm going to let people know who I don't have here.